Welcome. Today we're going to look at the Stack ISA Part 1. All we're going to look at is the concept of memory so far. So if you look at a CPU is two items. We're going to have our hardware, everything that is used to perform an instruction. There's going to be an interface that connects to memory. We're going to be taking items in and out of memory, performing operations inside the hardware. Well, what is memory? Well, let's view memory as a large set of index cards. Okay, so here we have an analogy that we're using. We have our index cards, and we have two pieces of information. We have the address. This is going to be how we find a location inside of memory. And then we're going to have our data. That is everything that's stored on this index card. Now, depending on how much memory we have, will be the number of index cards we have. So let's say we were going to have 4 megabytes of memory. Well, we would start at an address 0, and we would go to 4 million for 4 megabytes. All right, so we have some basic ideas. Well, we could say we could have all of these index cards, and let's just represent it as one large array. If we see, we have our address 0, 1, 2, 3, all the way up to, in this case, 4,000. Okay, so for each of these index cards, we know it's going to hold some piece of data. All right, so for a stack ISA, let's take that memory and let's divide it up into 3 segments. We'll have segment number 1 being a stack, segment number 2 being code, and then another segment being our variables. All right, so let's look at some C code. If we wrote some code out in C, we might have something like int x, y, and z. Well, this x, y, and z, I'm going to say that's part's going to be put into this variables. So I'm going to have some code, and let's say in C we wrote x is equal to y plus z. Well, this would need to be turned into assembly, and all that assembly instructions will be put into our code. And then we have this, what's left, which is the stack. The stack, this is going to be space that the hardware is going to use as temporary storage. They're going to be taking some information from inside the code, pulling some variables, needing some space to store some information as they perform actions. And all of this stack would be where we store all of that temporary variables. Well, the stack is just like what it sounds. Let's say it's a stack of index cards. So here we have an example, 3 index cards. There's always a bottom. In this case, the bottom is a 0. And there's going to be a top. The top is the value of 2, the address 2. Well, what's going to happen is inside our stack ISA, we're going to have 2 items. The item is we only have access to the top of the stack. So we can either add something new and put it on the top. So we can add in a 3, or we're going to process data that is found at the top. So we might process information that is found on address number 2. All right, so this gives us the idea of what a stack is in memory. And then in part 2, we're going to start looking at how we add and remove stuff from the stack, what instructions those will look like. So I'll see you back in part 2.